Hi, it's Daryl Carson, and I'm here this week to do my grandma video log. This week's subject, we're going to be talking about the action potential within the neuron. And so what we've got is human beings are electrochemical beings. And what does that really mean when we say electrochemical? It means that chemicals either have a positive or a negative charge. So we can actually polarize these chemicals by separating them with a membrane, and on one side make a positive and on the other side negative, so that the two sides do not have the same charge. So if we were to look at that, it looks like this. So the membrane could have positive chemicals on one side, negative chemicals on the other. It's very similar to a household battery where you have a positive and a negative. And when we look at this, this is the resting potential. This is the voltage of the polarization, because there's no action being taken against it, just like a battery. It's sitting there, it's got a resting potential. And this polarized membrane, it wants to depolarize because opposites attract, plus and minus. And so when this depolarization does occur, an electrical impulse is released. And so when you ask, how does this polarization happen inside the human? Well, there's actually these little ion channels inside the membrane, and they open and they close and they pump these chemicals across the membrane so they could push the positive ones out and keep the negative ones in and maintain this resting potential. And so what triggers this depolarization, you would ask yourself? Well, what it is you receive electrical impulses from some neurons, and then those some of these electrical impulses are weak and some are strong, and the receiving signal needs to actually exceed the threshold of excitation. And once it does that, then once this threshold of excitation is reached, then it triggers what's called the action potential. So we've got our resting potential, and then all of a sudden there's a change in polarization, a depolarization. It's called the action potential. And during this action potential, the ion channels open, letting in these positively charged chemicals into the membrane, which cause the depolarization and the impulse. And once this action potential has reached its peak level in just like 1 millisecond, then these channels close and they start the process of repolarization. During the repolarization process, the chemicals balance sometimes overshoots the resting potential for a brief moment, and this is called hyperpolarization. So we see we're at the resting, we have the depolarization, it comes up and it repolarizes and it hyperpolarizes. And so when we look at the neuron and we look at where it starts and then it ends, this is the action potential, where the electrochemical process shoots an impulse from one side of the neuron to the other.